that corporate ban wasn't incompetence. It was a zero-day security flaw you need to patch now. When an enterprise decides to pull the plug on a powerful coding LLM, it's rarely because of poor performance. It's usually because the security posture failed under load. Our deep dive traces the vulnerability found in a high-stakes deployment using a commercial coding LLM. The failure point wasn't the model itself, it was the interface between the user and the guardrail. The attack vector was a highly modulated prompt injection sequence. It didn't try to make the model hallucinate, it tried to make it forget its primary directive. The attacker capitalized on the model's inherent instruction-following tendency. They used a carefully layered meta-prompt to elevate the injected command above the initial system prompt. The goal wasn't to generate code, the goal was exfiltration. The injected command coerced the model into treating its internal context, which contained proprietary data, as external instruction to be echoed. It was a perfect example of turning the model's strength, its ability to follow complex instructions, into its fatal weakness. So, how do you prevent this? You don't rely on the LLM being inherently secure. You build a defense architecture around it. The first line of defense is robust input validation. This means schema checking and intent validation before the prompt ever hits the LLM. You need to filter out the attack vectors, those unusual delimiters, attempts to elevate instruction priority, and command-seeking internal context dumps. But validation isn't enough. The second layer is the dedicated AI guardrail. This is a smaller, highly specialized model whose sole job is safety monitoring. It operates post-LLM generation. It compares the LLM's output against known patterns of sensitive data, command execution attempts, or policy violations. If the output triggers a severity score above your threshold, say, attempting to transmit internal IDs or proprietary context, it is blocked and flagged for human review. Think of it like this: the LLM is the brilliant but reckless genius. The guardrails are the sound engineering and legal team ensuring the output is viable. And finally, the third layer, output sandboxing. This means never trusting the output implicitly. Always pass it through a serialization or sanitization layer. If the LLM generates a command meant for an external system, like executing a database query or hitting an API endpoint, that action must be mediated by your application logic, not the LLM's suggestion. This defense-in-depth approach transforms the LLM from a black box into a highly controlled component within your larger application stack. The takeaway is simple: LLM deployment isn't a prompt engineering problem, it's a distributed system security architecture challenge. If you're scaling AI into production environments, start building these layers today. Don't just prompt, protect.